Thanks for watching. Today I'm working more on my stock market model. And tune in. I'm cleaning up the code base, making it, I'm going to make it a lot easier to use. So this is the model in the repository here. You can go to this repository, the link's in the description, and you could get the code that I'm building. And I'm updating this every day. Or that's my goal. Stream every day on it and update every day. So I'll go over really quick where I'm at and where I'm going to go from here. So let me move. Oh, is this updating? Oh, my screen's not updating. Sorry, just a sec. Let me take this off. It was working right before I started this stream. Oh no, not audio capture, screen capture. And let's put it on my monitor. Okay, good. Now it's live. So, yeah. Now here I am. Okay, so all that to say, I'm updating the code. Go to the GitHub if you want the code, start if you find it useful. It's in the description. So I'll give a brief overview of where I'm at and what I'm going to be working on today. So this is what I've done so far. I retrieved data. I tried a couple different methods. First I was using spy data, and then I found a really good database. I explained that in the GitHub. So you can go get that database. It's a SQL database, and you need to use Dolt, which basically will put a SQL server on your computer. So you need to pull the data and then put it on your computer. And so I've retrieved the data. This is initially just spy data, and then once I got the Dolt data, there's some things I had to do to clean it, and so this is kind of proving that it's cleaned. Here it's accounting for a stock split. Once I had the data, I went ahead and did a basic analysis. So this is looking at fundamentals, not price data. And then here's, I'm comparing different pharma stocks. Pfizer, Merck, Johnson & Johnson, AstraZeneca, Novo Nordisk, against each other. So this is kind of very basic analysis. You can see how is a stock performing in a sector. And I did lots of, this is just an example, but there's lots of comparisons I made. So the next thing to do was to put this into a model that I can train and kind of spit out outputs. So this is a light GBM model. GBM stands for gradient boosting model. And so this is like a random forest, but it uses a different strategy and it goes a lot faster. So I trained a basic model, and got the feature importance for stuff. And so you kind of need data. Then I'm training a returns model, and then I'm training I'm refining a portfolio strategy to work on that returns model. And so I got a portfolio strategy that actually works really well. So this is the how it worked using some amount. This was the first strategy I used. This strategy was a little bit different, but what I found here that was really interesting is that the fewer number of stocks that the portfolio strategy is picking, the better it performs. So here you see 500. It's let me move my window so that I'm not in the way. So up here you see 500. That's making 500 picks every single day. And pink is the SPY line, S&P 500. Green is the model line. And so you see if it's making 500 picks, the model's slightly underperforming the S&P. 100 picks, it's matching the S&P. 20 picks, it's beating the S&P. And 1 pick, it's way better than the S&P. And so that made me think, okay, let me see if I could find a sweet spot. So here in this plot, I looked at the Sharpe ratio. You want to make sure you have something that you can use, you want a Sharpe ratio above 1. And you see that the only Sharpe ratio that's above 1 is if I'm only making 1 pick per day. and I wanted to see. And above 1 is kind of the threshold. If it's below 1, you definitely don't want to use it. But really, you would like something that's a fair bit above 1. And 2 would be great. But like 1.5 would be good. But if this was just barely getting above 1, and so that shows that this isn't really a robust strategy. This was tested on all of 24 and 2025. And so that's basically a big bull run with this tariff period right here. That's why I thought it was a good time to test. So it's a bull run, but it had a huge drawdown right in the middle of it. And so here I refined the strategy, and I said, okay, let's get a threshold for the strategy. So instead of picking the top amount with positive returns, I'm going to threshold it at a certain value. And so you see thresholding between 0.5 and 0.2 doesn't really increase the Sharpe ratio at all. But using 0.53, we get a much higher Sharpe ratio. And 2.5, using 0.54, I get a really high Sharpe ratio of 2.5. If I did 0.55, it's not making any picks at that point. And then these are the 3 different lines. So you see that the purple line is 0.54 threshold, and so that tends to be lower than the other lines, but you can see it's a much more robust strategy because it doesn't have big drawdowns like the other lines. And so that suggests that it's a lot safer. And but the problem is the returns model that I got, the best performance I could get was 51.5% directionally accurate up or down. And so at the end of the day, you want something better than that. I would like something 53% or 54% to implement that. And that means I need to do a lot of prototyping. And before I can do that, I really need to restructure the code. So here on the left side is what my current code looks like. So there are a bunch of scripts to get the stock universe, a bunch of scripts to train the model, and a bunch of scripts. Oh, this says the same thing, but this should say portfolio method. So basically this ends up at dozens of files. It's really inefficient, and every time I want to try something new, I either need to overwrite a file or add a new one. And so I'm already at dozens of files in the repository. Let me move this so that you can see it. Yeah, but basically there's dozens of files in the repository, and this is really inefficient. So I'm now bottlenecked by the code base, and this is making it so that I can't rapidly prototype and try out different things. And so before I go ahead and, before I can get to the rapid prototyping stage, I need to clean up the data. And so I'm going to take this from dozens of files to put everything in a single file. And this is in Python. So these are all Python classes. First, I have the clean data. I already have all of the data retrieval functions in a single file, and so that's done. And I defined a bunch of filter classes for different filters, and those go in to define the stock universe. So you want to basically cut out crap from the stock universe. Penny stocks, things that don't have any volume because there's going to be a lot of slippage, stuff, and anything that's had a huge drop, stuff like that. Those are kind of going to make the model so that it learns the wrong things, and it's not going to be effective, not going to get a high percentage, the 53 or 54 that I want. So I'm using that to define a stock universe, and all those operations are in the universe class. That's going to be the input for training the model class, which again is going to be a single class, and it's going to allow for basically any inputs to the LGBM model. And any target that you could possibly want will be in here. And then finally, I'm going to use the model that I trained, feed that into a portfolio model, and same thing. It's going to be diverse and flexible, and basically be able to implement any portfolio strategy from this returns model that you want. And so once I have this built up, I'll be able to do rapid prototyping. Rapid prototyping And then I'll be able to run through a bunch of different strategies and find something that's effective without blowing up the code base to be hundreds of files. And you can see in the GitHub that it's already at hundreds or at dozens of files, which is a big mess. It actually might be over 100 if you include all of the data. So there's all these files, and then the data. There's so many data files, and there's so much stuff on my computer that I haven't uploaded to the GitHub because I realized the code base was just getting way too big. Hey Ash. No. Although that would be good if I should pre-record this and just throw it at the beginning of each stream. I basically made a PowerPoint because every stream I would start and then I just fly through here and nothing's really well defined and it's not succinct. So I figured I'll make a couple of PowerPoint slides talking about what I did and then what I'm working on, because everyone's always asking, what are you working on? Yeah, so this is where I'm at now. The stock universe and the filters for the stock universe, like I said, the clean data is already done, and I've done filters and the stock universe. So today I'm working on the returns model. And let me see, I put a timeline in here. So by February 11th, that's 4 days from now, I want to have a complete analysis that's working. So basically this file will be working and I could start on the rapid prototyping. By the end of February, I want to have a working model ready. Now that's kind of ambitious. I might not have that. But once I have a working model, I want to basically test it on paper trading, track it in an Excel file and see how it does. And then by the beginning of April, I want to go live with the model and start trading with it with some small percentage of my portfolio to be safe. Okay, and so just for this first item, completing clean analysis, yesterday I finished the universe class, and today I'm working on this model class. So I'm 1 day behind, but I gave myself 3 days of float. So yeah. All right, so let's get into working on the model. Oh yeah, so then the other thing about this is I want to be able to add any features for training to the model and then add any targets that I could possibly want to the model. So yesterday I went through and got a big list of features and targets that I want to get, which is kind of a lot. Okay, have a good night. That's the problem with streaming. It's worldwide, and so somebody's always going to bed. Somebody's always asleep. Different parts of the world. It's hard. Oh, before you leave though, suggest a time. What's a good time to stream? It seems like late night streams do really well. It's the middle of the day here. I'm in California. It's 11:30. Okay, so yeah, now I want to implement the features. So each one of these features will have its own method for getting it. And then when I say add features, first I want to make sure that that's a valid feature that I actually have. And when I add targets, I want to make sure that's a valid target that I actually have. But I have to think about how do I want to do this. I might just want to make a general class for features. Okay, so let me see. Let's pull up Google AI Studio. And I want to see if there are Python implementations of getting at least some of these. Because I think there should be. And I'm pretty sure when I looked before there were. Here are... It's 1:02 a.m. So let's see. You must be in Asia, I would assume. It's 1 a.m. That means you're 14 hours ahead. Yeah, so that's 1 a.m. So probably a good time is what, like 7 p.m. your time? So 5 or 6 hours ago. Good night. Um, Here are all of the targets and features I could possibly want to use for my LGBM I'm training to predict for I'm training to make a portfolio strategy for the stock market. Are there any Python packages which currently exist that implement some of these? I have a pandas data frame of price data, open, high, low, close, volume, and I want to add the features and targets to this data frame. Oops. I could just paste this. Oh, I guess not. Okay, let's see. You can implement nearly every target and feature on your list using a combination of Pandas TA, Pandas, and ML FinLab. Well, ML FinLab, I'm not gonna pay for something. Purchase, of course. Oh, and they don't even have a link. How stupid. Okay, how can I use this? Let me put some music on. I don't have anything in my earphones. I need something good to listen to. What kind of documentation is this? That's not gonna work. TA lib. Okay, let's look up TA lib Python. Okay. Pip install TA lib. Alright, now let's see if it works. Python package index TA lib. In another life. Okay, so let's see if we could just add something in here. So test TA lib. First, I'm going to put in a description of each of these tests. So this is demonstrates liquidity filter is working. Next, we have test price filter. advanced stats. And then what else do we have? Okay, so the first thing we're going to do in this test first read the data. So we want to get one account symbol. Forward, we can say. And then we can say, where is the example for TA lib? TA lib, okay. And then we could say plot df.date. So date, and then let's just look at the close price. All right, first we should probably make a figure. And I'll make it, let's make it 9 across by 5 high. And then axis is x1 equals fig.add subplot 111. And then we're going to make a twin axis because the y scales will be different. So ax2 is equal to ax1 dot twin x. And then here instead we'll say ax1 dot plot label is close price. And then we could say ax2 dot plot df.date, and then we'll call this TA lib SMA. Oh no, those don't have to be on different axes. It'll look fine. I'll just take that out. x1.plot output ta-lib SMA. Standard moving average. Okay, what else can we do in ta-lib? My window looks small, make it a little bit bigger. Nothing can catch me. Why do I feel this body so bad? Okay, standard moving average, then let's do Bollinger.
Excuse me, streamer.
Yeah.
Would you like a half of a roast beef sandwich?
No, I'm good, thanks.
No, roast beef sandwich would be like yesterday.
But yeah, that's good. I'm just not too hungry.
Hi, buddy. You already went out today, right?
Yeah, I took them out this morning.
I'll take them later.
Okay, so this is SMA from ta lib, and this is Bollinger bands from ta lib. I don't know why that's giving an error. Okay, then we could do ax1.plot, df.date, ta lib upper label equals upper Bollinger band, ax1.plot, df.date lower Bollinger band, and then middle. Okay, so and let's add a grid. Okay, so just the price MPL PLT. I don't have matplotlib. From matplotlib, import pyplot as PLT, plt.style sheet.use. I think that's how I do it. Tests. I did it in tests. plt.style.use. Clean tests. So let's make the dark ground black or background dark. Okay, now this is color will be lime. This will make magenta and a dashed line. These will be alright, we want some, I guess the middle one we can make golden. And these ones we can make dashed. Oh, and then I have to show plt fig ax1 dot set y label date ax1 dot set, oh no, x label is date, set y label should be price. What's up with Buddy? What, buddy? And then ax1 dot legend, and then show it. ax1, and the title should be testing TALib functions on Ford data, right? Ford, yeah. Is that it? I think that's it. Now show it. That's what I was worried about. Polars, did I ever use polars? Oh, someone said to use, I think Xiao said to use polars. If you're on an Apple ARM machine, this is likely due to running Python under Rosetta. From quickest to best long-term, quick fix. Mini Forge. But it will, so if I don't do this, it's going to run slowly. Experimental. So this will probably make it run slower, but I'm just going to do the first thing. Okay. Good. Let's put this in the PowerPoint. So what's today, the 7th? Okay, so really all the indicator stuff I don't want to so I'm gonna do another class. Clean analysis. And what will this do? Class add features. I'll call this feature getter, feature retriever, feature adder. Okay, I have to think about this. How do I do this? Alright, I have to go to the bathroom really quick. Bum, 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 bum. Okay, so I think I actually, might want to make that kind of its own thing. So I'm gonna make a new script called features. And then when then I could just pass in a list of features. Define the features, pass in a list, and then each will have its own function. So let's make two parent classes. And then we can say self.name is equal to name. And then we'll do a target class. And then these will each have a general function. Okay, so then I could say get is a function, and then when we say retrieve, and that's going to be overwritten in each feature class. And then this retrieve function. Do we even need it? Oh yeah, we do. I need some music. Nothing is satisfying when it comes to music. I can't get no satisfaction. Albums. Alright, so the arguments are df, data frame to get feature on. This is the number of days to look back. Returns pd.series. Which is pandas series of the feature data. Come on and hustle those, that's if you're still living. So number 1, look back over specified time frame. Number 2, get feature over this time frame. So we want to look back. The key difference between feature and target is feature you're looking back, target you're looking forward. But then in the class, when do we want to specify number of days? So I want to, when I'm in this universe class, or the model class, I want to say add features, and then just say, I'm going to put a dictionary in here that gives the names, so then I could just pass in string, and then it'll go in through, so for feature, in features, feature dot get. So for features, we could just do negative. I guess I could just call this variable feature. We're a champion. Okay, so we want to say whether it's a feature or a target. I don't think I need retrieve. That you were a champion, alright. Yeah, so then I could just say valid features. strong string. Alright, valid targets. Okay, so what do we want? Price momentum. That don't kill me, can only make me stronger. Filter. Let's get lost tonight. You could be my black Kate Mouse tonight. So the name is lag return. Do anybody make real shit anymore? Oh, this should be in the init function. Okay, and then we're gonna change name. Detailed name is equal to. Also want to add in self here. So detailed name is function string self.name underscore num days and then D for day. So this will look like lag return underscore 5D. Okay, so when we're getting it, we're passing the data frame, lag return. Okay, and then if we want the log return. I don't know, is this the most efficient way to do this? Let me think. I could put everything into a function, but that doesn't sound much better. So I also need to define valid data frame. And I don't want everything to be talking to each other. Oh, I forgot to add a comment in the chat. Let me do that real quick. Here's my comments. Okay. Okay, I guess the data frame should have log returns as a default, right? But it should calculate on the whole data frame. Let me ask the AI, is this a good strategy? I'm building up a model in clean. I'm building up the model class. I need the capability to add features and targets I specified before. The model class should be flexible so that I can specify any features or targets that I may want to use. My strategy is to make classes for all possible features in features.py and then add them. The idea is to make it flexible. The idea is to make it flexible. Is this an efficient strategy? I want period space. I want to be able to. I want to avoid a single function which calculates everything, since that will be inefficient. Another option is to add all possible features and targets in the initialization of the model, comma, and then I can then only use ones which are specified. But I'm worried this would take up too much memory, having so many columns in my data frame. With, let's see, 1 year was 200,000 rows, so 10 years would be like 2 million. So I'll say with millions of rows. Give an assessment and tell me what you think would be best. So let's add clean analysis and features. run. Ugh. I go for mine, I got to shine. Yes. Okay. Ha 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 ha. Monolithic function. Yeah, okay. That was my intuition. What is that sklearn pipeline? How do I know what function? Okay. Um. Yeah, so let's go to the PowerPoint. Okay, so next I need to develop strategy for making feature / target retrieval efficient. We want to make it both efficient and flexible. Okay, let me go add the files. Added test for TALib. Oh, I just clicked on it. Added script for features and targets. This is my life, homie. You decide yours. All right, so that's it for now. I'll do another stream on this tonight. I work on this every day, so subscribe if you think this is interesting. Go to the GitHub in the description if you want to use the code. And then star it if you think it's useful. That helps me out. And yeah, that's it for right now. Thanks again for watching. Adios.